In this video, we're talking about the unit circle, and the unit circle is one of the most important topics for all of Trig. Now, what I wrote here is memorize it. We're going to talk about the unit circle and what it is and what it's used for. But the most important thing for this concept is that you must memorize the values in the unit circle. So what are the values in the unit circle? So first off, a unit circle is a circle with a radius of 1. Now there are specific points on this circle that are extremely valuable throughout Trig. So let's take this first point right here on the unit circle. So let's say the coordinates there are x and y. Every point around the unit circle we can describe by its coordinates, x and y. And then the distance, because the radius is equal 1 of the unit circle, this has a distance of r equals 1. Now what we can do is we can make a triangle. And what we want to be able to do is we want to figure out what is the x value of this triangle, what is the y value of this triangle. Now I need to back up slightly. What we're saying is this angle here is 30 degrees, that central angle. So when we have a triangle that has a central angle of 30 degrees in a unit circle, what is the x value and the y value in this triangle? And what we end up with is we get an x coordinate of root 3 over 2, and we get a y coordinate of 1/2. And we can also state what this angle is in radian measure. So we know that it's 30 degrees if we're in degrees, but we could also say that that is pi over 6 in radians. So when we talk about memorizing the unit circle, this is what we're talking about. If we say, what are the coordinates at 30 degrees? Well, we would say root 3 over 2 and 1/2. Now, traveling around the unit circle, this next position has an angle of 40 degrees, so this central angle right here is 40 degrees, and the coordinates there are root 2 over 2 and root 2 over 2. So x is root 2, y is root 2, or x is root 2 over 2, y is root 2 over 2. And then we know that the angle measurement in degrees there is 45 degrees, and the radian measurement is pi over 4. And then traveling around to this final position, that angle, it's kind of hard to see in yellow here, but this angle here, that angle is 60 degrees. So at 60 degrees we have an x coordinate of 1/2, we have a y coordinate of root 3 over 2, and then the angle measurements there, well, we have 60 degrees and pi over 3. So traveling around the circle, each section we call a quadrant. So there's 4 quadrants for the unit circle, and we label them with Roman numerals. So this up here is quadrant 1. We're going to say this over here is quadrant 2. We have quadrant 3, and then quadrant 4. And what we'll notice is that everything that happens in quadrant 1 gets reflected into the other quadrants. So the coordinates, the values in red in the first quadrant, get repeated in quadrant 2, 3, and 4. The only difference is that the signs for x and y may become negative. So starting at this next in quadrant 2, we're just going to proceed counterclockwise. What we have here is this angle is 120 degrees. In radians, this is 2 pi over 3. The second position is 135 degrees, or 3 pi over 4. And then lastly we have 150 degrees, or 5 pi over 6. And the coordinates for each of these angles, well, this position right here, this first one, is a reflection of 1/2 and root 3 over 2. So what we notice is that in quadrant 2, the x-coordinate is negative, but y is still positive because we're still above the x-axis here. So there are the coordinates. Okay, moving down at 135 degrees, well, that's just a reflection of the coordinates at 45 degrees. And again, just the x-coordinate is negative. And then moving down to 150 degrees, we are going to reflect what's happening at 30 degrees. So we have root 3 over 2, but that's negative, and positive 1/2. All right, and things are going to proceed in this same fashion. So here, we haven't talked about what's on each axis, but that's 180 degrees. Next we have 210 degrees, then 225 degrees, 240 degrees. I'm just going to keep going. This is 270 degrees at the point 0, -1. And then we have 300 degrees, 315 degrees, and 330 degrees. So those are all the angles in degrees. And then if we want to give the angles in radians, well, at 180 degrees, that's the same thing as pi radians. At 210, well, that is 7 pi over 6. At 225, that is 5 pi over 4. At 240 degrees, that is 4 pi over 3. Okay, and then at 270 degrees, that's at the point 0, -1. That's the same thing as 3 pi over 2. At 300 degrees, that's going to be 5 pi over 3. 315 degrees is 7 pi over 4. And 330 degrees is 11 pi over 6. So those are all the angle measures in the unit circle. From there, we need to figure out what the coordinates are. Now I'm going to leave the x and y axis for now. So at 210 degrees, well, 210 degrees is just the same coordinates as what's happening at 30 degrees. The only difference here is that both the x and y coordinates are negative. So negative root 3 over 2, negative 1/2. So same values, just negative here. 225 degrees is the same as what's happening at 45. And again, both values are negative. And then at 240 degrees, we have what's happening at 60, and that's negative 1/2, negative root 3 over 2. And then lastly, in the fourth quadrant, the x coordinates are positive, the y coordinates are negative, so we can just reflect what's happening in quadrant 1, but let's keep x positive, y negative. So this will be 1/2, negative root 3 over 2. This will be root 2 over 2, negative root 2 over 2, and then root 3 over 2, negative 1/2. Now looking at this, it looks a bit overwhelming. The things that you need to be able to memorize and recall are the angles as we go around the unit circle, and what the coordinates are at each of those angles. So if a question says, what are the coordinates at 60 degrees? 60 degrees, you need to be able to say 1/2 and root 3 over 2. If we say, what are the coordinates at 5 pi over 4, that's down here, the coordinates are negative root 2 over 2 and negative root 2 over 2. Now we haven't yet talked about what's happening on the x and y axis fully, so let's go to a new blank unit circle and we can complete the information. So the angles, well, right here at this point at 1, 0, that's an angle of 0 degrees, and it's also at 0 radians. Okay, moving along to the point 0, 1, well, that's a measurement of 90 degrees. So 90 degrees is equal to pi over 2. Moving down to negative 1, 0, that's halfway around the circle, so that's 180 degrees, or pi radians. And then lastly, at 0, -1, that is 270 degrees, or 3 pi over 2 radians. And we already have the coordinates are given for us. So at 0 degrees, the coordinates are 1, 0, right here. At 90 degrees, 0, 1, and so on. So we are already given the coordinates on this particular graphic. Now, if we recall how we could define the trig functions using points in the coordinate plane, we said that sine theta is equal to y over r, cosine theta is equal to x over r, and tangent theta is equal to y over x. Now, this idea comes in very handy when we're talking about the unit circle. Now, what's unique about the unit circle is, well, it has a radius equal to 1. So when we are defining the trig functions in this way, these r values are just going to be equal to 1. So if we want to find the sine value at some angle, if it's on the unit circle, we just need to look at the y-coordinate. Similarly, if we're talking about cosine at some angle, all we need to do is look at the x-coordinate, because x over 1 is just x. So let's look at a few examples here. Sine of 60 degrees. So what this is saying is, let's look at the unit circle. Let's locate 60 degrees. 60 degrees is up here. And then sine is defined as y over r. Well, again, r is equal to 1, so this is going to be root 3 over 2 over 1. So root 3 over 2. For now, I'm going to write this over 1, but we don't really need to, so it's just root 3 over 2. Cosine of 4 pi over 3. 4 pi over 3 is down here in the third quadrant. We know that x is negative down there. Cosine corresponds to the x value over the r value. And we have an x value of -1/2. So -1/2 over 1, which is just -1/2. And then tangent at 7 pi over 6. 7 pi over 6 again is in quadrant 3. Tangent is defined as the y value over the x value. So we have -1/2 over -root3 over 2. Now we need to simplify this. The 2's can cancel. We get -1 over root 3. And then we need to rationalize that denominator. So times root 3 over root 3. And we end up with -root 3. Root 3 times root 3 is root 9, or 3. Okay, so let's do a few more. Sine at 315 degrees, that's in quadrant 4. 315 degrees is down here, so the sine value is y over r, so y over 1, -root2 over 2 is what we'd have. Cosecant at pi over 2. Well, cosecant is the reciprocal of sine here. So cosecant is going to be r over the y value. That's what we're going to end up using. So at pi over 2, that is, pi over 2 is up here. Our coordinates are 0, 1, and we have an r value equal to 1. So cosecant is r over y, so this is going to be r over this y coordinate. So it's 1 over 1, which is just equal to 1 here. Now, secant at pi over 2 is a little bit different. It's going to be r over the x-coordinate. Well, the r-coordinate is 1. The x-coordinate is 0. So what we say is that this is undefined because we cannot divide by 0. And then 3 more. Cotangent at 5 pi over 3. Well, cotangent is just the reciprocal of tangent here. So we're going to say that's x over y at 5 pi over 3. 5 pi over 3, down here in quadrant 4, we said x over y, so 1/2 over -root3 over 2. So we have 1/2 over -root3 over 2. I'll let you rationalize this on your own, but you're going to end up seeing that this is root 3 over 3, and that's negative. So cotangent at 5 pi over 3 is -root 3 over 3. Secant at 180 degrees. Well, secant is the reciprocal of cosine, and cosine is x over r, so secant is going to be r over x. Well, at 180 degrees, the r value is 1, the x value is -1, so this will be 1 over -1, which is -1 here. So 1 over -1, which equals -1. And then lastly, cosine at 240 degrees. 240 degrees down in quadrant 3, and the cosine value is -1/2. So when I talk about needing to memorize the unit circle, this is the reason you need to memorize it. Anytime we have a question like this, sine 60 degrees, cosine 4 pi over 3, tangent 7 pi over 6, sine 315 degrees, etc., etc., you're going to need to recall the coordinate values, which is what we got as the outputs here. You're going to need to be able to recall these without looking at the unit circle. So on a quiz or well, I guess you may not have a quiz, but if you have an exam, a question could be asked like this, and you're going to need to be able to say what the coordinate value is. Now, you may have time to draw out a unit circle on your exam, and that's what many students do. Many students recreate this image on their own. So they draw a blank circle, and then they write in all of these angle measurements and then all of the coordinates as well. And we'll talk later about some tricks for you to be able to memorize what's happening on the unit circle. But at the very least, you need to be able to, when you are given an angle, you need to be able to say what the coordinate is based on the trig function.